Radicals lesson 5. So this lesson is broken into two parts, and you will need a graphing calculator. It says, consider the radical expression square root of x. On the grid, sketch the graph square root of x. So we're going to go to our graphing calculators. I'm going to go y equals, top left corner for y equals, clear if there's something in there. Square root is second x squared, and then the x button. And we want to go graph. So it's going to look something like that. So to plot it accurately, let's go to our table. So second graph is how we get to our table. So we have some points. We can plot 0, 0. Another nice point is 1 and 1. Another nice point is 4 and 2. And then from that, we can draw a nice curve. Okay, so square root of x. So square root of 1 is 1, square root of 4 is 2. That's where that comes from. State the domain of the graph. So the domain is the location of the x's. So our domain in this graph is starts at 0 and then it's above 0. So x is greater than or equal to 0. For what values of x is the radical expression defined? Root x defined. So that's saying that what values of the expression. So basically, because it's greater than 0, it's all positive values. And the reason for that is because we cannot take a square root of a negative. It has to be a positive value. And that's why our graph is above 0 as well. Okay, so now let's sketch the next one. So it's defined when x is greater than or equal to 0. All right, let's look at the next graph. On the grid, sketch square root of x minus 2. Grab your calculators, go back to y equals second x squared x minus 2 bracket. And graph it. Push the graph button. There it is. And so you can go to second graph to get some tables. So you can see error, error. The graph doesn't exist. It doesn't start till 2. 2 and 0. And then we have 3 and 1. 3 and 1 is a point. And 6 and 2. Okay, so it says state the domain of the graph. So like, where does it exist? X has to be greater than or equal to 2. It says for the radical expression, state the restrictions on x. So basically, because this square root, we can't take the square root of a negative number. It's just not possible. So that means that the inside has to always be above 0. It has to be positive. So we know that x minus 2 has to be greater than or equal to 0. It has to be positive. And so that's where we get, if we add 2 to both sides, x has to be greater than or equal to 2. X is greater than or equal to 2. And so that restriction it comes from because the inside has to be positive. If you put a 1 in there, I get 1 minus 2 if x is 1, which is negative 1. You can't take the square root of negative. So explain how to determine the restrictions algebraically. Basically, what we need to do is take the number under the square root, whatever's under the square root, and set it above, greater than or equal to 0. So whatever is under the square root should be greater than or equal to 0. Greater than or equal to 0. And then we just rearrange for x is greater than or equal to some number. Consider the radical expression here. So the square root of 3 minus 2x, let's grab our graphing calculators, and we're going to go the square root, so quit out of here, go back to Kirk, y equals second square root 3 minus 2x. And this push graph again. So this time it's going the opposite direction. So it actually starts at 1.5, if you can see that, which if we go to our table, it won't really show that. second graph to go to our table. It gives us 1 and 1. And are there any other points that we have? Going up, -3 and 3. -3 and 3. So let's plot those points, and there we go. Okay, so the restriction this time is to state the restrictions on the variable. Well, it's the same thing as saying when they ask for the restrictions, it's the same thing as saying what's the domain. So what can x be and what can't it be? So the restrictions are what can x be? X has to be less than or equal to, because it's to the left. Remember, left is less than 1.5. Or you could also write that as x is less than or equal to 3 over 2. 3 over 2 is 1.5, just written as a fraction. So here, determine the restrictions algebraically. So how do we do that? Well, when you have the square root of 3 minus 2x, what's underneath the square root has to be 0 or greater. We can't have a negative. So we're going to take the inside, 3 minus 2x, and it must be greater than or equal to 0. So now we're going to rearrange for x. So I'm going to subtract 3 because we have a positive 3 there. And I have negative 2x is greater than or equal to negative 3. And we still want to get x by itself. So I'm going to divide both sides by negative 2. Now do not forget, in inequalities, if we divide or multiply by a negative, if we divide or multiply by a negative, it switches this direction of the inequality. It flips the inequality. It's hard to read that one. Let's go down here. Flips the inequality. So that means what we're going to have here is now the negative 2 divided by negative 2 cancels itself out. So we have x. So it used to be greater, now it becomes less than or equal to, and two negatives become positive 3 over 2. So radical expressions involving square roots may have restrictions on the value of the variable because the square root of a negative number is not defined. So a radical equation is an equation which contains a radical. A value of the variable which satisfies the equation is called a root. In this lesson, we will solve radical equations involving one radical graphically and algebraically. So today we're going to look at graphically solving it. So graphically, let's first, it says, first algebraically. Algebraically determine any restrictions on x. So we're just looking at restrictions. So all we ever have to do is just say, okay, what's under the square root? And we take that and we set it above 0. Greater than or equal to 0, and let's solve for x. Add 2, add 2. So x has to be greater than or equal to 2. And you can just test it. If I put 2 in, does it give me 0? Yeah. If I put 3 in, does it give me a positive? Yes, it does. So same idea here. A restriction we're going to get from what is underneath the square root. We're going to set that greater than or equal to 0. Then we can solve for x. Minus 1 to both sides. And then, oh, that's a negative 1. Divide by positive 4. And so x is greater than or equal to negative 1/4. Try another. So we take what's under the square root, and that has to be a positive number. So greater than or equal to 0. Then we solve for x. So I'm going to move the minus 2 to the other side. And I have negative 5x. It's greater than or equal to negative 2. And last, I'll divide both sides by negative 5. And remember, if we multiply or divide by a negative, we switch the direction of the inequality. So x is less than positive 2 over 5. All right. This is a cubic root. Can you have negative cubic roots? Yes. So no restrictions. There's no restrictions here. X is an element of the real numbers. It could be any number because it's a cubic root. We consider the radical equation square root of x plus 1 equals 4. State the values of x for which the radical equation is defined. So that's saying, okay, basically, what are our restrictions? So x plus 1 has to be greater than or equal to 0. So if we subtract 1 to both sides, x has to be greater than or equal to 1. That's a restriction on the square root. So that's where the radical is defined. X is greater than 1. Explain how to use your graphing calculator to find the solution to the equation. So if we have square root of x plus 1 equals 4, what we're going to do is we're going to say y1 equals the square root of x plus 1, and we'll say y2 equals 4. So we're going to graph these two lines. So the first one is y equals the square root of x plus 1, and the second one is y equals 4. And we're going to graph both of them. So the square root of x plus 1, we want to get a nice, we can go to the table of values and get some points. So it starts at -1 and 0 for our radical. Then we have another nice point is 0 and 1. Another one is 3 and 2. Let's get as many nice ones as we can. 3 and 2. Let's go down and see our next one. Here we go, 8 and 3. So 8 and 3. And there it is, 15 and 4. 15 and 4. So there's my graph. Just going up. And then my other graph was y equals 4. And so we want when the two lines are equal to each other. So just like in Math 10, we want the intersection point. It's not a very straight line. Try this again. There we go. Move it up a bit. There we go. So y equals 4. So we want the intersection of the 2 points because we want when they're equal to each other. So what we're looking for is the intersection. Now, with our graphing calculator, we can use the intersection feature. So now that if you push graph, we have to change our windows. So remember, the window button is the second one beside y equals. Let's make the same as what they have here. So x is between -5 and 20, and they're going up by a scale of 1. And then between -5 and 5 for y values. If we graph it, then now that's the same graph that they have. We have to zoom out so that we can see the intersection point. So now we can find the intersection. Second trace, number 5. We can scroll over to where it is, or we can just push enter, 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 and there it is, 15 and 4. Now we just want the x value, and the x equals 5, equals 15. So that's my solution. So x equals 15. And how can we check our work? Well, we're going to do that right away. So state the solution to the equation x equals 15. How do we check it? If we have the equation square root of x plus 1 equals 4, let's plug in our solution of 15. Does the square root of 15 plus 1 equal 4? What's the square root of 15 plus 1? Square root of 16. And does square root of 16 equal 4? Yes. So that is the solution, x equals 15. So this is the end of the first part of the lesson.